Hello, Jason. So here is number 73. Suppose a 1.054 gram sample has some chloride ion. How much chloride ion? 10.3% by mass. Right there, right there, we can start working on some data. So obviously, we're going to need chloride ion. So how much chloride ion have we got? Well, they said I'll do this in brown. They said 1.054 grams of something, which is 10.3%. 10.3% chloride ion. So how much chloride ion, are we talking about? Ha 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 ha. You know where this is going, right? Of course you do. 0.103 equals, now there's only one unit here, that's grams, so the answer is going to be grams. It's going to be grams of chloride. Chloride, okay. So that ends up being 0.109, I think, 0.109 grams of chloride ion. So we have some data to work with. So starting with 0.109 grams of chloride, the question is, what mass of silver nitrate? Blah, 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 completely precipitate. Okay, the word precipitate means to take something out of solution and into the solid state. So AQ means aqueous, dissolved in water. AQ means aqueous, dissolved in water. So when you add silver ions to chloride ions, they're both aqueous, you immediately get the chloride ions out of the aqueous phase and into the solid phase as silver chloride. Of course, you're also getting the silver ions out of the aqueous phase and into the solid phase. But these guys in this problem are interested in the chloride ion. And they want to know, how much of this do you need to get rid of all of this? That is, how much of this do you need to react with all of this? Okay, I know what you're thinking. You're thinking, this is just silver, but not silver nitrate. Yet, they're asking for the mass of silver nitrate. So, how is that going to work? How can we get the right answer? Well, we'll get it like this. In the rules of naming chemicals, in black, in the rules of naming chemicals, silver nitrate, what happened to the S? Yeah, what happened to the S? Okay, silver nitrate is AgNO3. And AgNO3 is soluble in water. So that means AgNO3 makes Ag plus and NO3 minus in water. Okay? So this means what we have to do is move screen. Okay, here we go. So what we have to do is figure out how much of this we need to use. And then for every 1 mole of this, there is 1 mole of this. So then we can, if we know the moles of Ag we need, we will also know the moles of AgNO3 we need, because all of the Ag comes from AgNO3. I will proceed with this problem, right? And when I'm done, you must do the same, right? And then you will see, after you've done the problem yourself, the understanding will start to come. If you don't understand it completely, do the problem again, by yourself, right? And then the understanding comes. So here we have, what did I say? I said 0.109, right? So we have 0.109 grams chloride ion. Now, we're going to use the chemical equation that they had there, you know, the one that goes Ag plus Cl minus makes AgCl. We're going to use that chemical equation. All right. So to use that chemical equation, I need to be speaking in moles. So there are 35.45 grams of chloride ion in 1 mole of chloride ion. Right? So far familiar, right? Did that in order to get rid of these guys. Now the problem, my calculations are about moles of Cl minus. I don't want moles of Cl minus. I want moles of Ag. So 1 mole of Cl minus is required for 1 mole of Ag plus. Oops. 1 mole of Ag plus. How do I know it's 1 mole and 1 mole? Of course, I use the chemical equation, right? This is obviously balanced. 1 mole of this, 1 mole of this. Okay, back to my work here. And now this problem is about moles of Ag+. But in fact, I don't want moles of Ag+, do I? I really want grams of silver nitrate. So I continue moles of Ag+ in the bottom, moles of AgNO3 on top. Okay, so how do I know 1 mole of AgNO3 it corresponds to 1 mole of Ag+? How do I know that? From this, of course. Remember this? Right here. AgNO3 dissolves in water to give you Ag plus and NO3 minus. That's where the Ag plus comes from. It comes from AgNO3. And there's 1 mole of this and 1 mole of this because there are no coefficients in this chemical equation. And no coefficient means an invisible 1. Do you know what I mean? I know you know this, but do you know what I mean? Okay, good. Okay, so back to the calculation. Now, that's moles of Ag plus canceling with moles of Ag plus. Now my calculation is about moles of AgNO3. Is that what I want? Let's see. No, he says what mass of silver nitrate, AgNO3. So let's convert this into grams. How do you do that? I think you know. You use your friend, the periodic table. 1 mole AgNO3. Okay? So, to save time, instead of adding things up, instead of adding up all of these guys on the periodic table, there's the Ag, and the N is 14 and the O is 16. Instead of doing that, let me show you how. Do you know how to use Google? Google does a great job of this. It's one of these special Google tools, So you just say molar mass silver nitrate. It just tells you straight up without you having to click a link. It just tells you. So there it is, 169.87. Back to our work here. 169.87. 169.87. And then I will cancel sound effects. And the only thing left standing is grams of AgNO3, and that's what I wanted. So that's great. I'll get the answer doing that. Shall I go through the whole motion of calculating the actual answer? Shall I? I can. Let's see. 0.109 divide 35.45 times 169.87. We have 0.522. So that's 0.522 grams silver nitrate needed. Okay, now let's see the exact wording of the problem. It said, what mass of silver nitrate must be used to completely precipitate? What mass of silver chloride will be obtained? Okay, so you need at least this amount of silver nitrate. So it's important to put at least. Why is that important? Because if you put more than this amount, will you still satisfy the problem? Will you still precipitate all of the chloride ion? Meaning, will you still react with all of this? Yes, you will. You will have some AgNO3 left over, but you will still react with all of this. So that means the correct answer really is at least this much. You could have 0.6 grams, that's okay. You could have 1 gram, that's okay. But you must have at least this amount. Now, how much silver chloride will you produce? Well, let's have a look. Shall we? The eraser, please. So, I will now erase. Okay, I will erase this. And I will erase, no, get rid of everything else. Okay, so to find how much silver chloride I will produce, silver chloride is just this, this product. So I know how much of this I have. How much of this will I produce? This is just stoichiometry again. So I start with what I have, 0.109 grams of chloride ion. Change that to moles. 1 mole of chloride ion goes with 1 mole of, in this case, I'm looking for AgCl. Whoops, the brush. AgCl. Okay? And then 1 mole of AgCl is how many grams? I can add that on the periodic table. Silver is 107.9. Where are you? Where's my work? Oh, here we are. Calculator. Silver is 107.9, and chloride ion is 143.35. 143.4 grams AgCl. So I canceled some junk. AgCl is gone. AgCl is gone. Now the only units left standing are AgCl in grams. That's what I want. So, deploy calculator. 0.109 divided 35.45 times what? Times 143. Oops. 0.4. That's 0.441. That's 0.441 grams AgCl. That's it. Okay? So there were 2 answers. This answer and that other answer. I suggest you do this problem on your own once you get the gist of how to do the calculations. Okay? Thanks, Jason. I will stop this now.